How are you watching this video right now? It might be on your phone, desktop, or tablet. Connecting devices to the internet yields amazing benefits. But what exactly is the Internet of Things? Well, in a nutshell, IoT is the concept of connecting any device to the internet and to other devices. All devices in the network interact with each other to collect and share data. But I'm sure this explanation is not satisfactory. So let's go ahead and understand what exactly IoT is. We'll understand why IoT is necessary, the hardware and protocols used in IoT device architecture, its security standards and practices, and the Internet of Everything. Finally, we'll look at some of the use cases of IoT and its impact on industries. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update.
So why the Internet of Things? As a learner, you should learn IoT, as it provides better scope for future data scientists, as well as provides for promising career opportunities. You can also build and manage your own IoT for your home. As a company executive, you should learn IoT, because it will help you measure everything in the business. You also get real-time metrics, actionable data, and better connectivity across industries. After completing this course, you should be able to explain the concept of Internet of Things comprehensively, describe hardware, software, and other connectivity building blocks of IoT, describe design considerations pertaining architecture, framework, and interoperability, explain the security considerations with IoT pertaining to vulnerabilities, explain Industry 4.0, Internet of Everything, and social IoT. And finally, describe IoT framework in enterprises.
In the context of IoT devices, hardware can be divided into two categories: general devices and sensing devices. The general devices do the embedded processing and connectivity for the platforms. They are connected either by wired network or wireless interfaces. They are the main component for data collection and information processing. The current home appliances are a classic example of such devices that are controlled by a sensor. These sensors help solve common problems. Apart from sensors, actuators are another important device in IoT that performs similar functions with different capabilities. They work as interface between sensors and machines and collect various information like humidity and light intensity. This information is computed using the edge layer, which typically sits between the cloud and the sensor. They are the layers that store the intermittent transfer of information. Finally, the back-end server of the cloud processes this information. Both the sensors and actuators are the chief components of IoT. The sensors measure temperature, humidity, light intensity, and other key parameters of home environment. The second most crucial aspect of IoT is device management platforms, or DMPs. The DMPs, as they are shortly called, are the platforms through which the assets interact with the software layer through network gateways. DMPs come with various functionalities, which include firmware upgrades, security patching, and reporting of metrics. They also help develop alert mechanism for industrial equipment with more open source OS like Arduino. Overall, it is an important aspect of the management of the device penetration. Connectivity blocks. Connectivity blocks collectively is considered as the backbone of an IoT setup. There are various connectivity layers like USB, CAN protocols, and Modbus. The next generation protocols of Wi-Fi are LoRa and Zigbee. They can interface with any application or modules, a small device embedded in an object. The entire landscape is called gateway architecture. The various ports are 232.485 from USB. They come with gateway architecture. The device interface is important for the data transfer and enables digital transformation with third-party applications and systems. Communication protocols and standards. Let us try to understand the various communication protocols available to set up an IoT. The first is the satellite. This enables a cell phone communication through an antenna situated within 10 to 15 miles. They have a stable and universal connection. The second is the protocol is the Wi-Fi, and is based on 5 GHz frequencies. It provides internet access within a certain range and are an affordable option. It has well-protected protocols. The third is the radio frequency. It is the easiest form of communication. A few examples are Zigbee and Z-Wave, which use low-power RF radio. It consumes low energy, which is very advantageous. It is relatively simple to configure. The fourth in this list is the RFID. It uses wireless electromagnetic fields to identify sensors and objects. The good thing about it is that it does not require power. The fifth is Bluetooth, which is useful for short-term and short-distance data exchange. It is present in every smartphone and has sensors. The final one is near-field communication, or NFC. It uses electromagnetic induction and loop antennas. It comes with encryption, has low-speed communication, and is used for short-range data exchange. Future of IoT connectivity. IoT connectivity is the future, the launch of new technologies like 5G. The 5G with low latency and higher throughput will increase the penetration of IoT. 5G cellular technology is supported by the network for virtualization, even for the common use case, such as for a tea vendor, real-time predictive analytics can be available. So, overall, the delivery time is reduced with IoT. 5G and IoT are embedded technologies. Both can be sliced and diced for predictive analytics and real-time business decisions. 5G will help devices connect through a network with high-speed bandwidth. IoT device architecture. There are 4 layers in the device architecture. The base layer consists of IoT devices. This includes all the components, like sensors, with the ability to sense, compute, and connect to other devices. Let's move on to the second layer, which is the IoT gateway or aggregation layer. This layer significantly aggregates data from various sensors. These 2 layers form the definition engine, and they set the rules for data aggregation. The next layer is based on cloud. It's called the processing engine, or event processing layer. It has numerous algorithms and data processing elements that are ultimately displayed on a dashboard. This layer basically processes the data obtained from the sensor layer. The last layer is called the application layer, or API management layer. It acts as an interface between third-party application and infrastructure. The entire landscape is supported by device managers and identity and access managers, which are useful for security of the architecture. Many individuals and organizations have contributed to create and set this standard. It covers the entire network and endpoint systems. It brings a structural approach with security controls in place. It provides a demarcation based on its uses for enterprise that build IoT products. This standard has 85 detailed recommendations and a structured approach that can fit into any IoT ecosystem. It has a flexible framework addressing the diversity of the technology aligned to the regulation. It also has risk modeling capabilities for any organization to choose from, including endpoint ecosystems. The standard is very flexible and comes with the inbuilt risk assessments for any organization to adapt. Overall, it is an interesting standard and easy to get trained at. IoT security, best practices. There are many best practices in IoT security. Let us look at some best practices pertaining to IoT hardware. First of all, the hardware should be tamper-proof. They should have undergone dynamic testing with specific data protection algorithms and should be updated on firmware and patches. The network components must be authentic with encryption, kernel controls, and division of networks into segments. Other security measures include privacy protection for sensitive information and other regulations like safe harbor statements. There are many value drivers to help the Internet of Everything. The key drivers are employee productivity, supply and logistics, customer experiences, innovation, and time to market. Asset utilization. All the factors are tightly linked to generate a new revenue gains for any enterprise. Time to market and innovation. This will help with the competitive index of the organization. It will help discover MVP to reduce the cost of building and bring improvement in customer experience. Asset utilization is the form of digital, physical, and even smart assets. The asset discovery is the requirement for the establishment of the IoT ecosystem. Supply chain is also a key value driver and assesses the requirement of Internet of Everything. In addition to the drivers, there are significant elements. The elements stand in 4 buckets. The first is data, which encapsulates sending and analyzing data. The second bucket is the people, who are always connected and have contextual subject mapping with the real-time world for decision-making. The third bucket is the things which link people to machine with endpoints, IP addresses, and sensors. The last bucket is machine to data, which talks to the business value and action iteration, essentially building simple models to achieve corporate results. Internet of Everything. Growth engine. The Internet of Everything comes with a growth engine for any organization. It includes people, who are the most valuable resources. The process of making the right effort for the things that includes the physical devices, other objects, and the data taken from sensors to make actionable insights for decision making is important. People, process, things, and data are the growth engine elements that gives a company an edge in the digital transformation world. With data privacy and transparency mechanism, it is important for every organization to follow internet ethics and compliance. IoT and fleet management. Let's discuss some use cases of IoT. The fleet management is a classic example of IoT in application. In this domain, IoT is mainly used to track vehicles from one point to another. Using IoT technology, the entire fleet can be monitored with the support of RFID chips embedded within every car in the fleet. The same RFID can also be used to track products such as consumer goods, electronics, and food items. You can get real-time information on the routes that the fleet takes. There are OBD devices that can be used to track vehicles' behavior and performance, including fuel consumption and mileage. This can reduce the total cost and provide greater return on investment. According to a recent study, the IoT market will increase to $8.28 billion by 2021. Sensors linked to artificial intelligence help the bankers track all the activities in the back end. The advancements of mobile phones and digital assistants, along with 5G connectivity, makes customer experience seamless. First and foremost, it is data. Data is the new oil. Financial institutions have structured and unstructured data of the customers. They can slice and dice the data for profiling, segmentation, product launches, and digital services enablement. The data can create a large economic drive and give rise to new business models like NFC banking, digital assistance banking, and social media banking. With this transformation, Internet of Things provides a competitive advantage to the banking, insurance, and financial services, while the end goal remains to help customers save money and give a bundle offering. Let's understand how IoT revolutionizes various industries. With the advent of the Internet of Things, there are many industries experiencing digital transformation, such as financial services, healthcare, manufacturing, communications, energy, retail, and transportation. IoT has initiated changes at all levels: user, infrastructure, and large-scale applications. Analytics with real-time dashboard and IoT support allows informed decision-making for businesses. This also means that IoT is introducing a new revenue model for enterprises around the world.
So that is it for this video. If you found it interesting, make sure to like and share it. Thank you for watching, keep learning, and stay tuned to Simply Learn.
Hi there, if you like this video, subscribe to the Simply Learn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.